All right, good afternoon, everyone. It's very exciting to see a full room here and that you all got off the beach. I didn't actually make it out there yet, but plan to before sessions get started tomorrow. So I do have a Chief Marketing Officer title, and often in these more technical conferences, folks say, oof, a marketing pitch, not so exciting. This isn't going to be a marketing pitch. I have 2 degrees in biology and chemistry, and I worked in ophthalmology research for years before coming into the storage industry, which is a long, convoluted story that's better over beers, but here I am. There's a couple things related to what I've been doing that I think really applies to this session. So I was the founder of the Active Archive Alliance, and where that came from was myself and some unstructured data software companies were sitting around talking about, this is when I worked for a tape company. And we were talking about, we have all these petabytes of storage sitting around, and people want to be able to start to make that data searchable. How do we do that? How do you take all those archives or backups that are sitting on tape somewhere, offline, in a tape library, and start to make those searchable? And that was really the genesis of the concept of active archiving. We thought about how do you tag and apply metadata as the data goes into the system. Once it's there, how can you keep the metadata alive while the data is cold? Really worked through that. That was about 5 years ago. Ended up creating the Active Archive Alliance, which now you see in RFPs and all these different things, the concept of I need an active archive. Sometimes it's tape, sometimes it's disks, sometimes it's cloud. But that was really, I think, the start of, within the storage industry, us thinking about how do you take data and make it much more usable and more of a live kind of system. As things were starting to move towards this direction. There wasn't a term called big data at the time. That marketing term didn't exist yet. But then as things started to proceed, I work in the SNIA group, which is the Storage Networking Industry Association. They do standards. And one of the interesting things in the standards groups are big data isn't a standardized thing. Everyone is doing it differently. There certainly isn't going to be some 10-year process of making a standard that you all are going to adhere to because it's changing so quickly. So within SNIA, it's become more of an education to the vendors on this is how quickly the users are moving, and if you vendors can't move as fast as the users, you're going to be obsoleted. And that's kind of an interesting, different direction versus a few years ago where you all waited until you saw your fiber channel over Ethernet standard, then you put it in your data center and tested it for a few years. Things have flipped, things are moving a lot faster. So kind of interesting. And then now I work at DDN. And DDN moves fast. DDN is a huge innovator in technology. We're willing to take risks on figuring out what that next trend is going to be, working collaboratively with our customers who are really our partners, and doing development to continue to solve this very fast, rapidly changing market. So that's a little bit about my background. I think that finding the path to business value in data is kind of a fun topic to think about as we go through this session. So some of the things to consider for big data, I think that as I've started, I talked to journalists, I talked to customers, and a lot of people are saying, well, have we crossed the chasm? Is big data real today? Is it still a marketing term? Obviously, you all are here because you either believe in it or you really want to believe in it, and you're trying to figure out how to justify it in your organization. But as I was coming out here, there was something I was reading on the airplane today. I flew out to Orlando from Denver and had some time on the plane. And I was reading an article that was talking about how big data today is really changing the world, where just a few years ago it was a curiosity. And it was around Steve Jobs and Steve Jobs' cancer, that he had probably as much money as anyone in the world to throw at his medical care. And what they had done is he was one of the first people to have his entire genome sequenced, the whole thing. And then they also took different pieces of his genome as it was changing, and also sequenced the cancer, sequenced the drugs, and could figure out how to target his treatment to the point that as the cancer continued to modify and evolve, as those sequences changed, they could target treatment to it. The problem with it was, at the time, it would take weeks, it would take months to be able to match the sequences and figure out how to target the cancer. If you just move forward to today, where our computing technology is, where analytics technologies are, there's this strong belief that they actually could have cured or at least kept him from dying from his cancer, because it wouldn't take weeks to get results, weeks to then target a treatment. By that point, the cancer's busily, doing bad things to his body, and they weren't able to recover from it. That things have evolved fast enough that they actually believe they could have kept him alive now. Kind of interesting to think about, given it's only been a couple of years. But then as you start to look at considerations for big data deployments in other areas, I believe the industry got a little bit stuck talking on, is big data all about Hadoop? If I don't have a Hadoop administrator in my organization, or I don't have a big commodity cluster with somebody run Hadoop data on it, I'm not big data. And I looked at the attendee list here. There's some folks from the supercomputing industry, some from the enterprise, some from research. And what you'll find is really big data is in every organization now. I mean, how you do searches on the internet and ads that pop up to you that are remarkably customized to what you're interested in, that's big data. That's predictive analytics around data that's being stored. Your spam filters, that's big data. As you start to look at the software that you're using to search your email inbox, that's big data. So it's probably in your organization somewhere, no matter what you call it. It's permeating into all the different software applications and all the different use cases. So I'm not sure that even a year from now, when we come back to this session, that everyone's going to be talking about, do I or do I not have a big data budget? It's going to be more, yes, I'm doing big data throughout my organization. How do I optimize? How do I, what's the right next application or platform for me? So as you look at where you see big data, there's a lot of really interesting case studies in here. I think we talk about science a lot because it's personal to all of us, how you can target medicine, cancer cures, those types of things we all care passionately about. But then as you jump over to financial services, for example, big data is used, and one of the things that I think is really interesting about big data is it doesn't even have to be that precise. And I think most of us think about banking and financial services as the most precise market in the world. None of us are tolerant of them, approximately getting our account balance right, or approximately getting the value of our stock right. But as you look at how they decide in back testing on where to recommend investment, on where to optimize the investments, you really can't be precise about what's going to happen in the future. But if you have a big enough data set, and this is just statistics, which I'm awful at statistics, sometimes I'm going to try to talk about statistics, but when you have a big enough data set and you look at what is statistically relevant, even 1%, 2%, as you start to see a trend, is enough to make really, really good decisions, better decisions than any human could. So compute technologies, as you look at financial services, are really, really common in making predictions around investments about what's going to happen in the market more accurate than any human being could have done in the past. Within manufacturing, one of the really interesting case studies that my company was involved, but there was a lot of companies involved, was around the failure analysis of the Malaysia aircraft, where they never found it. So this isn't even exactly a success story. But what happened was meteorological institutes, data storage providers, educational institutes, all took this data that they were all storing for different reasons and were able to, in light speed, literally, start to share that data so they could try to find Malaysia Airlines, to find the Malaysia aircraft when it was in an unknown location over the Indian Ocean. And what I thought was interesting about that is it was research institutes down in Australia, for example, who were storing the data for completely different reasons. And then you had the manufacturer of the aircraft who knew things about their flight simulators. They were able to merge all that data, and without even knowing really what questions to ask, they were able to triangulate on where they thought the aircraft was. Now, all this just goes to show that, different versus structured data, which in the past, as data came into the system, if you weren't storing it in a certain way, applying metadata in a certain way, really structuring the data in a certain way, it became unusable to anyone else. Unstructured data is just the opposite. As long as you have it, and you have the right kind of systems with enough horsepower in the systems to be able to analyze it, you can get results out of it. So I don't think that crossing the chasm from being not a big data organization to being one is quite as big as people used to think it was. You're not migrating databases in the same way. It's a different kind of thing. And then as you look at a couple other areas within the internet space, and I don't know if there's any cloud service internet providers here, are there? No. Okay, so just, I won't spend much time on this, but what you will find is interesting in the internet space is there's all the big bad, big brother stuff you hear about, that the federal government knows where we all are and what we're talking about right this minute, and there's worries about that. But on the other side, big data on the internet and in the cloud is really, really valuable. PayPal, for example, using big data, can identify when there's fraud going on with a transaction in literally less than a millisecond. And that's not because somebody, the hackers are smart. The guys who are going in there and trying to steal data are very, very smart. They're not raising their hand, electronically and saying, here I am, I'm trying to hack the system. But because of big data, we can still identify with reasonable confidence when something bizarre is happening. It's not always right, but it's actually happening. They're able to identify it pretty frequently. So lots of different things for considerations of big data, but no matter what organization you're in, you're probably using it some today, and you'll probably find just every application you download in the future is going to have some big data in it. So as you look at what big data is about, whether you're talking about analytics or you're talking about large capacity storage, it's all about getting to the data. Why people want big data is typically to be more competitive. It's more competitive for NSF grants, it's more competitive for end user business, it's more competitive because you've reduced risk in your organization, more competitive because you're able to drive up margins. Maybe it's something to do with the manufacturing efficiencies and how you can get more cost out of your manufacturing process. Again, all about business competition. Whoops. But what I think that most people are starting to find is it's not so much the applications that are the issue. There's a lot of applications out there that are very, very data aware, but there's a lot of bottlenecks within the systems that as you start to take your traditional systems that you may have out there, your networks, the way the backplanes are done, the way the processors are built, how much latency is built into the system, that's the biggest issue that we're starting to see in big data deployments is ultimately the concepts are sound, people like it, but then they go deploy it in their infrastructure and it just doesn't work. They find that there's too many problems somewhere in their infrastructure that you say, gosh, the results really aren't accelerating my business. My people are sitting twiddling their thumbs waiting for results to come back. This really isn't all it should be. So those are some of the issues I want to talk about today. So identifying the right tools for the job. Tabor comes from a huge HPC background. I do as well. I absolutely believe HPC technology is the right answer to this. And when I say HPC technology, that means a lot of things. It's networks, it's software, it's how you handle parallel jobs, it's how you do the storage, it's a lot of different things. But enterprise systems were designed for something else. They were designed for always up, always reliable, all 9 nines of availability so that never ever could you go back and be audited for email compliance issues and not be able to deliver that email. Big data is a little bit different. Big data is all about time to results. Big data is about time to be able to make the people who are asking questions of the system be productive. And so there's a different kind of system that's necessary. I'm going to make sure I stay on track here on time. The companies that are bridging the gap, we already talked about some of the industries, but what you'll see, and I have my company name up here because these are slides from a different deck, but you can really insert a lot of different HPC technologies in this. That what you'll find is versus a scale-out NAS type of system, versus looking at IT infrastructure that was designed for databases, that was designed for structured data, HPC technology is much, much faster. And you could argue Data Direct is a bit faster than our competitors or slower than our competitors in HPC. Any HPC technology is going to come out at the top on this. And it's because HPC was designed for performance. But it's not just designed for performance from the perspective of how much throughput you can get in the system, how many gigabytes or petabytes you can get in the system. But it's more about how you can use the data once it's in the system. That it's not designed just for streaming throughput off a big supercomputer. It's designed for mixed I/O, which is really what big data is. Big data is a bunch of different types of data coming from a bunch of different applications that all write I/O in a different way. And what problems that you typically see in the enterprise as you start to implement these infrastructures is you put it on your systems that perhaps were designed for structured data, handle IOPS really well, but can't do the mixed I/O and can't do the throughput. So you run a job against it for one application, works great, run it from another application, doesn't work at all. Get 10 applications running and it just brings the system to its knees. That's the kinds of things that HPC type technology are designed to do that really, really fit the big data environment well. So the kinds of results that you'll see is running this, I think this is fascinating. I don't think Hadoop and big data are synonymous at all. In fact, within my company, only about 12% of our big data analytics infrastructures are Hadoop. The other 88% are some other applications. However, you think about Hadoop as this big commodity cluster, right, that has 3 copies of data that run across these white boxes, and that's the standard deployment of Hadoop. But we're now starting to see people running Hadoop on parallel file systems. The reason they're doing that is because the more users that are coming into the Hadoop system, the more users that are actively using the data, you actually want systems designed for parallel I/O to be able to offer the performance that you need. So we're actually seeing Hadoop being moved over from saying, I want the cheapest storage I can get, to I want the highest performance storage I can get. Depends on the organization if that matters or not, if it's just a POC of the analytics versus actually putting in deployment. Where you are in the buying cycle will affect that, but it is kind of interesting to see you get significant performance gains running Hadoop on parallel file systems. There's some knobs you have to tweak to be able to make it all work together, but that's a good discussion for a different day. But then as you look at some of the others, you'll see even enterprise applications, SaaS, KX, all of these are being accelerated, are being actually designed and optimized for parallel storage systems, parallel network kind of setups to be able to run their analytics faster. And of course, if you're in the HPC space and you think oil and gas, manufacturing, any of the applications, oil and gas specifically, they've been optimizing for these places and for these kinds of technologies for quite some time. But in the enterprise, this is pretty new. So we're definitely seeing that crossing of the gap with the ISV application space as well. And then as you start to look at where is the market going forward, 9% growth is predicted in the HPC storage market over the next 5 years. That's healthy, that's good, it's not a bad market to be in, certainly. But almost 30% growth in high-performance data analytics, almost 30% growth in object storage. And I bring up object storage because it is absolutely starting to shift into those analytics applications as a tier of storage that they're using. And object storage does it for 2 different reasons. One is you have the desire to keep a lot of data. You don't know which data you're going to utilize often. So being able to pull data out of your object store into your analytics application is really interesting. Write data in through a high-performance parallel I/O type system. Once the data's in there, quickly move it off to object storage to either share it to other geographies or to store it till you actually need to query it. So having object store in an analytics application is really, really interesting and helps drive the cost of the system down. I see there's a typo over there, but at the very bottom right-hand side where users are moving away from traditional IT platforms, traditional IT platforms are great what they're designed to do. However, repurposing them and trying to do big data, trying to do analytics, trying to have hundreds and hundreds of users all running random queries that aren't structured in any way, traditional IT systems just don't work real well for that. They'll keep up and running, but you'll start to see a huge degradation in the kind of performance that you're getting. So requirements of a big data environment is you start to look at what kind of systems should you be considering? What kind of technology do you want to be able to put in your environment? If I say just move away from traditional IT infrastructures, what kind of things might you want to look at that some of those infrastructures have that you can maybe optimize by throwing some SSD at it or some caching at it? These are the different things that people are really looking at. And I'm going to go through these as we go through. So the first part, I can't emphasize enough, the parallel access is absolutely critical. If you think about traditional scale-out NAS, all the users' requests come in through a single node, and then in the back end of the cluster is where those requests are disparated out across the cluster. That works fine up until you start to have lots of different applications and lots of users actively using the system. Or maybe one user who just has a whole bunch of jobs running. Either way, you start to see, even though a system may be designed to be able to get, say, 8 gigs of throughput into the system, if you're running a lot of jobs that have different kinds of I/O, you'll see that drop dramatically to much, much, much less, like 2, 3, 4% of the system's capabilities. So moving to something that has parallel access is really important, and just being able to sustain the experience people want within an analytics environment. If you think about when you sit on the web, how tolerant you really are to waiting for results is pretty small. I'll go to a website and watch the little dial spin for a second, 2 seconds, and I figure, the site's broken, and I just close the window and go to something else. I think in big data, I think you're going to find the same thing with users. They're willing to wait a little bit for their queries to come back. They're willing to wait a little bit to get a response from the system, but if it's too long, the users are going to say it's a waste of my time, I don't want to use this infrastructure, I'm not interested. So maintaining that user experience, whoever your users are, is really important. Being able to sustain mixed I/O performance at scale is a really big deal too. So we run a lot of benchmarks at DDN, lots and lots of benchmarks. We have 5 different benchmarks labs around the world, and we do them in customers' data centers. And in these analytics infrastructures, and I can't say this is precisely right, but about 85% of our customers are doing analytics on our systems. So we have a lot of just technical experience in this area. What you'll find is when you start to fill a file system, when it gets to about 80% capacity, and this could be any file system that you look at outside of the parallel file system space, at about 80% capacity, you start to have some real problems with the system. If you have to do any node rebuilds, if you're doing data copies on the backplane between parts of the cluster, you start to see really significant performance degradation. Lots of different technical reasons for that. But when it comes down to why you really want to look at HPC technology is you can accomplish a big data environment that has high IOPS, high throughput, and the capability to scale its I/O. So you have scale out and scale up. So you can scale up your performance, you can scale out your capacity, and get linear performance as you go across that environment. You don't typically see that with non-HPC technologies. You'll find you have to buy an SSD array for one kind of I/O, a scale-out array for a different kind of I/O. Then you have to have a data movement application to tie those two together, which is different from your data analytics application. You start to piece it all together, and a CIO, a data center manager, starts to say, this is just too much work. It's too complex to integrate. Getting down to one storage system that can run directly with your analytics applications is really the goal you want to get to. And then you want to make sure that you're designed in for growth. I already talked about this, that as you look at traditional systems, when you get to capacity, you start to run into problems. You can have dropped frames, you can have dropped bits, you can have significant issues on congestion on the backplane. And that's one of the things that's different about HPC technology, that you have InfiniBand typically on the backplane or some kind of really high performance interconnect, and it can handle all those issues within the storage cluster as you're also actively working with the data in the system. And then as you look at storage and performance density, this is a bigger discussion around performance density than storage density. I mean, you may have data centers where you worry about how many gigabytes you can get per rack space, but it's more about how much performance can you get into a rack. How much hardware do you have to throw at a system to get the performance that you need? So again, I'm using DDN numbers because, that's who created the slides. However, I know for a fact if you put some of my competitors in here, you'll see the same kinds of, we'll be a lot better of course, but you'll see the same kinds of results. That if you look at a traditional scale out system, what's really interesting here is the number of controllers you need to get to your performance. So the number of controllers you need per petabyte of storage is very, very high. You have to throw a lot of hardware at the solution to get that kind of performance. In an HPC type technology, you look at, yes, depending on what JBOD chassis you throw at it, you can get really good storage capacity, but you need a lot fewer controllers. That's fewer things to manage, fewer things to monitor, fewer things to break, fewer things to keep up, you have your IT managers working with. It makes a big difference, but most important, it really helps with cost. Every time you throw hardware, there's actual cost in the vendor's manufacturing facility delivering those to you. If you can get less hardware in the environment and the same kind of performance, cost of your infrastructure is going to come down. It's going to come down significantly. Even with you guys being able to keep within your budget, with your vendor being able to make a little bit of money, nobody's going broke in that area because we've designed it for parallel I/O, we've designed it for mixed I/O, we've designed it that you can scale storage and performance together, that you can embed the applications in the systems, that we use InfiniBand backplanes so that you can actually avoid that backplane congestion within the clusters. So there's a lot of technology reasons for why this is, and it's not just marketing. As you look at it, it's about a 10-to-1 difference as you look across the different environments. It's just a different architectural concept. And then the integrated tiering is a big deal too. Instead of having to have a flash array, a different software caching mechanism, some kind of high-performance disk solution, some kind of lower-cost disk solution, a cloud solution, a tape solution. Integrated tiering makes big data much easier, and that's because then you can point your applications at your pool of storage, and whether you have SSDs or HDDs or tape or cloud, it's being presented through the same interface to the same users. So Mr. User who's in New York City who wants to have access to his data, regardless of where it's sitting, if it's in a cold archive, an active archive, cloud, high-performance disk, his application is running with the exact same mount point. And again, users are the hardest things to change. I think all of you would agree with that. Changing user behavior is very, very difficult. Being able to deliver performance, but also in a continuous user experience is absolutely critical. So not having to have multiple systems, moving data around with users going to one system for one kind of query, another system for another activity, getting it all into a unified system is absolutely critical to having a very successful big data deployment. And then that global collaboration piece, I think this is becoming more important. I wouldn't say this is a checklist criteria for everyone, but most analytics systems are attached, there's some kind of high performance compute attached to the storage. And it's usually within a single data center where you're working within that data, that the storage, the high performance storage is local to the compute and the analytics environment. However, sharing the data, sharing the results, within universities perhaps, 5 different universities all want to share their data so that their analytics environment can share a larger pool of data set to answer the different questions they have. That's becoming a bigger deal. In an enterprise, it may be different office environments. In a media and entertainment house, it could be different broadcast studios. There's a comparable for nearly every kind of environment you look at. But having some kind of integrated content distribution strategy is worth looking at. Even if you're just deploying a single data center today, there's a decent chance you're going to want to be sharing that data at some point in the future. And then starting to think about, do you want to be able to test your environment? Almost anyone can run a workload up in a cloud environment and figure out what kind of results do you really get from it. There's HPC technology in the cloud today where you can use high-performance computing, infrastructure, storage infrastructure. It's all wired together in the way that a big supercomputing facility would be able to access the data. And you can test your workload there. So if you don't believe me, or if you don't really know if your data set will see the kind of returns on investment, try it. Try it up in the cloud. It's cheap. Most of the infrastructures you can put up there for a couple weeks, get some results and decide if it makes sense to you before you start to buy. And I really recommend that. It gives you a chance to deploy it without having to have expertise in-house to set everything up, to get the budget without really knowing what kind of results you're going to be able to do. So try it up in the cloud first, but try it on HPC infrastructure. Don't try it on just AWS. You won't get the same results in AWS because they don't have the same kind of computing infrastructure up there. So in summary, I do believe that you can use big data. You can use your data as a competitive weapon, regardless of what your business line is within your organization, what your organization is responsible for. The problem with big data is just being able to deploy it fast enough, get the value fast enough to justify your budgets. And then also be careful to bring the right tool to the job. We see a lot of people think about big data infrastructures, and their thought is, I'll try it in the cloud, but they use AWS, for example. They try to use their current infrastructure. Maybe they've obsoleted their 10-year-old storage system. Say, hey, let's try our big data on that, and we'll see if it works. And you don't get the kinds of results that you're expecting to get, and then those initiatives die. So you do want to make sure you're using the right kind of technology to be able to have one of these be successful. So with that, I'm out of time, and I got through all my slides, except for my marketing one about DDN. We're fantastic, but we'll tell you more about us if you want to on our website, or myself, as well as Alan is in the back, and we can certainly talk with you while we're here at this session. So thank you very much.
Well, thank you. Great job. We have a little bit of time for some questions. If anybody has any questions for Molly, and if not, she is going to be around tonight. Yes.
Tom, great presentation, by the way.
Thank you.
I just have a quick question. You mentioned, rather than just taking up an AWS, cloud testing platform, you mentioned using a HPC cloud provider. Do you have any that you know of that you could just mention as
Other than DDN?
other than DDN?
So DDN has invested in 2 different HPC in the cloud services for just this reason, where we did in partnership with some of our university partners that they provision off about 10% of their supercomputer. We put the storage behind it and offer it as a cloud service. I know there's competitors out there, and I haven't done my diligence to tell you who they are. So I'm not, you guys in the room probably could tell me better. I know there are other HPC cloud services if you Google it. We do offer them as a company myself, but it's an evolving area for me too to learn about as far as who else is playing in it.
Great, thank you.
Any other questions?
I'll ask one question. So in one of the slides you had
one of the sections for financial services. Can you give more examples on financial services? What examples do you have?
Yeah, so within financial services, it's usually trading companies. It's on the so it's either on the trading floor. It's within some of the brokerage houses that we're starting to see adoption. It's not in traditional banking though. It really is in the trading environment where that high frequency trading can benefit from the acceleration and performance. We do, and it's not related to big data, you do see object storage interesting in financial services for other compliance reasons, but that's not really relevant to this discussion so much. So it's usually high frequency trading where we're seeing integration with the applications that they use in their environments, that they actually know how to tweak the environment, storage-wise, setting-wise, configuration, SSDs, the right mix of all those to be able to accelerate. Even just a few milliseconds makes a huge difference in that environment. So it's a very, very, very highly tuned environment that we find that we can accelerate in that area.
Any other questions? Back here.
Thanks. You mentioned that NAS storage kind of falls over when the number of users or the number of jobs it's running increases. Can you give us kind of an example of where you saw it just sort of fall apart?
Yeah, so where we'll typically see it is if you have let's just say most scale-out systems are designed to run at up to 8 to 10 petabytes of storage. It's just kind of a ballpark to say. When you start to fill those file systems up to about 70 or 80%, and you start to have it in production for a year, and there's some controllers going bad, there's some disk drives going bad, there's a lot of users accessing the system, what you end up doing is, along that back plane, it's constantly in a rebuild state, it's constantly in a rebalanced state, and the performance while it's rebalancing across that cluster can really degrade significantly. And we see this in our end user benchmarks a lot. Where if you have a high performance backplane and you have parallel access to the environment, you're balancing across the front end access to the system versus on the back end. And so all those different things around rebalancing, around rebuild, around at capacity, can the system continue to deliver read-write performance in the front end and the balancing in the back end? Typically they can't. So there's a lot of specifics you could go into. But when we run benchmarks, we always run them at essentially 1 or 2% capacity, 25, 50, 75, and 100% capacity of the file system. And it's at that 75 and 100% where typically our performance will skyrocket versus the traditional system, and they'll start to go down. Where in the middle, at the 50%, it just depends on how it's specified, but it's really in that point when you get full that you see ours will stay stable and theirs starts to drop off. And it's all reasons like that. Yeah?
Yes, in that slide that you show, showing the benchmark with the transactional data, the streaming performance, and the scale enterprise performance, you mentioned Violin. Have you benchmarked against other pure storage, perhaps with Fusion IO or SanDisk? Why Violin?
Because we had a benchmark there, and that is precisely why. So what we try to do is take, a lot of cases we can't publish a customer-specific environment, but really what we're trying to emphasize there is all flash arrays do have, they do handle IOPS well. However, they don't necessarily handle IOPS better than an HPC storage system. So in fact, in that environment, there wasn't any SSDs in our system. So we're benchmarking our spinning disk high-performance storage solution against a all-flash array. And we're seeing, and it all comes down to how we write the data into the system, the parallel access, ordering the storage to be able to optimize for high-performance writes, lots of different things in the software. So I think you would see similar kinds of behavior if you were looking at SanDisk or Fusion. Slightly different, but really when it comes down to it, that I think all flash arrays are pretty well designed to do a great job with structured data. I'm not an all flash array expert, so I don't want to say I know everything about why it comes out that way. But they're certainly very good at structured data. They're certainly good at caching, but when you have a lot of simultaneous unstructured data, they don't seem to do as well, and I honestly can't answer for you why that is. And I don't think SanDisk or Fusion would be a whole lot better, not an order of magnitude anyway, better than or worse than Violin from my experience, but I may not be the best technical person to answer that question for you. Probably colleagues in here could though.
Molly, I have a question around the banking industry, as you just mentioned, because I come from banking industry too. As you correctly mentioned, they are still towards the trending end and they're quite not there yet. It's mostly in the POC stage, I guess, but which area would you think, or which area are you guys seeing the trend going towards? Is it more towards the storage, or is it more towards the performance areas? I know we are considering Hadoop already, but in general, which way are you seeing the trend more towards?
I'm not sure I totally understand the question. You mean as far as
for big data? I mean, there are some companies which provide the storage solution, some provide the performance, as you mentioned. In the banking industry, whoever you're considering right now, are you seeing them trending more towards the performance area or more towards storage? Or both, or
it's really both, but with the focus being on being able to deliver performance.
Performance,
so
right.
It's all around. From my experience, I think I just turned off.
Because I haven't seen a lot of consideration towards the storage yet.
No,
at least in my company, I'm from Bank of America.
Yeah.
But we are, as I said, we are considering Hadoop, but that's more towards the performance.
So my experience, and I agree with you, that very rarely would a Bank of America type company say we need storage for a big data environment. What you have to do, and this is actually one of the challenges with big data right now, is somebody, an application specialist, data analytics specialist may select an application. Let's say they select Hadoop, for example, and find it's too slow, and it's because they don't have the right network infrastructure, they don't have the right storage infrastructure to get that kind of performance that they want out of it. So ultimately, anytime somebody's looking at analytics, they really do need to also investigate the hardware infrastructure underneath it to get the results they want. And that's actually really the whole purpose of this presentation in a lot of areas is we find if you have software people making decisions on the analytics, and then they're either repurposing hardware or buying from whoever procurement typically buys storage and network from that's in the price list, that's where there's been a lot of problems in big data deployments, that it doesn't come together the way people think it would, and it takes years for them to figure out why. So yeah, I think people are looking for performance, but performance requires everything to be considered.
In essence, they should both go in parallel.
That they should both play?
In essence, you're saying they should actually start thinking both in parallel.
They should, yeah.
I get one more question here.
What is your experience with reliability between different parallel file systems with DDN?
Reliability. It has a lot to do with what kind of features you build into them. As far as do you want to do snapshots or do you not? There's really only we support GPFS and Lustre. There's CXFS and some other ones out there as well. What we have found is the latest version of Lustre, which is 2.5, and the latest version of GPFS, which is 4.1. If you don't put all the data protection features into them, they're actually relatively equivalent. If you had asked me that before Lustre 2.5 came out, I wouldn't have said that at all. Lustre used to be a lot less reliable. I don't think that's the case today. So now it's a matter of, do I put snapshots and other things in? Do I turn those features on or not? But I think the latest releases, they're relatively equivalent.
Molly, thank you very
You're
much.
welcome.
And Molly will be available later on, and to her colleagues from DDN. Did a great job.
Thank you.
you.